The fifth reaction of alcohols is called a pinacol rearrangement. The starting material for pinacol rearrangement is a vicinal diol, two OH groups on adjacent carbons. How do we make vicinal diols? Osmium tetroxide dihydroxylation, okay? Anyway, so under acidic condition, vicinal diols can rearrange to form ketones. So here's an example. One of the OH group becomes carbonyl, a ketone carbonyl, and the other OH is removed to become water, and on that carbon it will have an alkyl group moved from the adjacent carbon. Anyway, we will take a look at the mechanism to explain this. The key here is vicinal diol as the starting material and under acidic condition. The first step in the mechanism, alcohol, acidic condition, so protonation. One of the alcohol, oxygen, will get a proton from the solution to form the alkyl oxonium ion. The second step is the carbocation formation. So the protonated OH2, now the carbon-oxygen bond will break water as a leaving group to give the carbocation. If the diol is not symmetrical, the key here is we want to form the most stable carbocation. So if diol is not symmetrical, the OH group that is attached to a more substituted carbon will be protonated and form the carbocation. Okay, so we want the most stable carbocation. Next step is the rearrangement step. Now we have a carbocation, we have OH on its adjacent carbon. So the lone pairs of electrons on that OH group on the oxygen could come to the carbon to form an oxygen-carbon double bond. At the same time, we have to break a bond on the carbon. So one of the alkyl group attached to that carbon will migrate to the adjacent carbon that has the carbocation. In this particular case, we have a methyl group shift along with the pair of electrons in the carbon-carbon bond. All right, so here's the product. Carbonyl forms and the methyl group shifts. Okay. The last step is the deprotonation on the carbonyl oxygen. So you have another water molecule gets the proton on this oxygen to give the final product, which is a ketone. So the key step here will be step number 3, when the carbonyl forms and one of the alkyl group shifts. All right. So now I want you to follow the mechanism that I just explained and work on these two reactions. Please note that the first reaction, we have a diol and it's not symmetrical. the carbocation will form on the most substituted carbon. Okay. And for the second one, when the rearrangement reaction takes place, the ring size will change. Okay, so work on these two reactions and we will explain this in class.